We're now going to begin section 9.3, where we will discuss the hyperbola. We're going to begin with a definition for our hyperbola. Note that we have two versions of the formula that we will use for the equation of a hyperbola with center at HK. The first formula begins with the x value. And this is the hyperbola where the foci are aligned horizontally, which means that our hyperbola, which is basically two parabolas that face away from each other, that our hyperbola looks something like this. We're going to have a foci on the inside of each of these parabolas. And so this is saying that the foci are aligned horizontally, so they are aligned across. And so this happens if the x value is first in the equation. On the other hand, if the y value is first in the equation, then our foci are aligned vertically, which means that we have a parabola that opens up and we have a parabola that opens down. So we'll have a foci on the inside of each parabola. Remember, the parabola wraps around the foci. And these foci are aligned vertically up and down. And so that's how we're going to tell the difference. We're going to look at whether the x value is first in the formula or the y value is first in the formula to tell us the direction that the hyperbola is turned. In either case, the foci are located c units away from the center, where c squared is equal to a squared plus b squared, and the vertices are located a units away from the center. So to sum that up, we want to remember that when we're looking for the foci, we're going to be using the c value, and when we're looking for the vertices, we're going to be using the a value. We also want to keep in mind this version of the formula, which is slightly different than the version that we saw for the ellipse. A hyperbola has two asymptotes. The asymptotes enable us to graph the hyperbola, and these asymptotes have very specific formulas depending on how the hyperbola is turned. So if the equation of our hyperbola starts with an x, then the equation of our asymptotes look like these two values. If the asymptotes of our hyperbola, if our hyperbola begins with the y, then the equation for our asymptotes looks like this. Now we're going to come back to these slides as needed as we start to work some problems. So our first example asks us to graph the hyperbola. It gives us the equation and to indicate the asymptotes on the hyperbola. So we're going to begin by pulling off what we know from this equation. So right off the bat, I recognize that the x value comes first. So I'm going to go back to my formula and remind myself that if the x value is first in the formula, that the parabolas open one to the left and one to the right. Okay, so I'm just going to do a very, very rough, quick sketch here just so I don't forget. I've got a parabola opening to the left and a parabola opening to the right. Okay, we also know that our center point is going to be denoted by the numbers inside the parentheses, and we're going to have that same opposite relationship that we've seen happening with the ellipse and the parabola. In other words, when we go to talk about the center of this hyperbola, we're going to use, in the x parenthesis, we're going to use the opposite of what we see here. So if we've got a -2, then the center x value is going to be a +2. And in the y parenthesis, if we have a -1, then our center y value is going to be 1. Okay, so we know the center. I'm going back to my formula. Note that the a value is always first and the b value is always second. Okay, so let's go back and look at our specific equation. If that's the case, then this is my a squared and this is my b squared. And so I know that the a value is going to be 5 because 5 squared is 25, and the b value is going to be 2 because 2 squared is 4. And I also have a formula that I can use to determine the c. So remember that my formula for the c squared is equal to a squared plus b squared. So c squared is equal to a squared plus b squared. We can plug our values in and determine the c value. So I'm going to put a 5 in for the a and a 2 in for the b. So 5 squared is 25, 2 squared is 4. So my c squared will be 29, which makes my c value the square root of 29. So remember that we said that the vertices were determined by the a. So let's use that to find the vertices for our example. So what I'm going to do is I'm going to go ahead and start graphing this and trying to be a little more specific. So I'm going to go ahead and mark my center point at 2, 1. And we know that our vertices are going to be determined by this a value of 5. And so I'm going to move over 5 in both directions. So that's 1, 2, 3, 4, 5. So that's a vertex here. And then I'm going to come back this way. 1, 2, 3, 4, 5. And so that's a vertex there. So I know now that my vertices, I have the point 7, 1. And I also have the point -3, 1. Now they didn't actually ask me to find those, but that's going to help me in drawing the graph. Now, the next thing that I'm going to do is I'm going to go ahead and think about finding the equation for the asymptotes. All right, so remember again that the formulas that we use for the asymptotes depend on whether your hyperbola is open to the left and to the right or up and down, which is determined by which variable comes first. So for us, remember the x is coming first. And so our equations will look like these two equations. And so I'm going to go ahead and go back to my screen. I'm going to write those equations down. All right, and then we're going to find the equations of those asymptotes. All right, so my equations were y minus k is equal to b over a, x minus h. And then I had the same version of the formula except that there's a negative in front of the b over a. So that's going to give me the other asymptote. Okay, so let's plug our numbers in and let's see what we get. So for my h value and my k value, that's going to basically be the same parenthesis that we had up here. Because remember that this is x minus h and this is y minus k. So I'm going to go ahead and plug those in. So I'm going to have y minus 1, and I'm going to have x minus 2. And then this fraction, b over a, is going to be 2 over 5. And then we're going to have the same thing over here, except that we're going to have a negative. Now, what I would like to do is I would like to graph these asymptotes. So you can use your calculator, certainly, to graph these asymptotes, or you can actually plot a couple of points and sketch them out on your graphs. And so I think I'm going to go ahead with the points, but you should feel free to use your calculator if you would like. All right, so I'm going to take this one, and I'm just going to use a table of values real quick, and I'm going to pick some easy points to plug in. So, for example, I think I'm going to start with an x value of 2 because I know that that's going to cause this parenthesis to become 0. And so let's plug that in and see what we get. Make a little room here. So I'm going to have y minus 1 is equal to 2/5 times 2 minus 2. And when this 2 minus 2 becomes 0 and then I multiply it by 2/5, that entire side is going to zero out. So I have y minus 1 is equal to 0 or y is equal to 1. So that gives me 1 point that I can plot for my asymptote. And so that point is actually going to be my center point right here. Okay, and then I'm going to come up with one other point that we can use to connect. So why don't we use 7? And so I'm going to plug a 7 in for the x. So 7 minus 2 is 5, which is going to make those 5's cancel. So we have y minus 1 is equal to 2, or y is equal to 3. And so that gives me a second point that I can plot. Alright, I'm going to extend that up a little bit, and then I'm going to plot that second point. So over 7 up 3, and I'm going to go ahead and just sort of dot those 2 points together, and that makes my asymptote. Okay, and now I'm going to do the same thing with the other one. So I think I'm going to use the same points. That should be easy enough. So again, if I put a 2 in, this entire side is going to zero out, causing the y to be 1. And if I put a 7 in, let's see what that does. So y minus 1 equals negative 2/5. 7 minus 2. Y minus 1 is negative 2/5 times 5. Again, those 5's are going to cancel. And when we add 1 to both sides, we're going to get y is equal to negative 1. And so let's plot that point. Over 7 down negative 1. Remember, your other point is at the center. And so we'll connect those two. Forming our other asymptote. And so what you're going to see happen is this hyperbola is going to be drawn, and those asymptotes are going to sort of be your boundary lines, your guide for how wide to draw that parabola. So in other words, this parabola is going to come in very close to that asymptote and then come in very close to that one. And we're going to see the same thing happening here. It's going to come in very close. All right, and so obviously not the best graph there, but we'll look at the one they did in the book and we can see that we have the same thing there. Okay, so that is one example of how we can use the equation of the hyperbola to draw a graph, and specifically how those asymptotes help us in knowing how to draw those parabolas.